Okay, we'll start in a few more minutes. 2 more minutes. Yeah, okay. Hey, all right. Let's begin, everybody. How's your lunch, everybody? Has everyone had lunch already? Or not yet? Had lunch already, yes. Everyone else? The rest of you, have you had lunch already? Had already, What do you all have? I had Subway just now. Subway. What about you guys? Anything nice? Salmon and mashed potato, huh? Why so weird combination, man? Where do you get salmon and mashed potato as a combination? Your mom cook? No wonder. I don't think you can find any salmon and mashed potato combination outside. Hmm. Okay, okay. All right. Now, do you all go for the chemistry class just now in the morning? Yes, you had almost missed a bit. No lah, I know some of you sure late one. Just now the Mandarin class also, some come in after 2 minutes, after 3 minutes, after 4 minutes. All kind of pattern, I know. Got go to chemistry just class just now. Okay, right. Let's have a look at what we're gonna do today. So for today, right? We're gonna mainly focus on three things. Okay, so we're gonna mainly focus on. Wait, let me open up the notes. Okay, we're gonna mainly focus on linear motion, number one. Okay, and then we're gonna focus on inertia. Sorry, momentum. Okay, momentum number two, and then inertia and momentum together lah, and then impulse and impulsive force. Okay, so we're gonna do these three things because all of you, your midterm exam, you will definitely have these three topics lah. Okay, as for chapter number three, the gravitation one, not all schools have that topic for your exam. Okay, from what I've asked you all. So we are only going to do that in our normal class. So if you have any questions about that, right, you just ask me during the normal class lah. Okay. For today, we focus on mainly chapter 1 and chapter 2 only. Okay, especially chapter 2 lah. Now, because your scope is so limited, there's so little chapter that's coming out for your exam. That means it's gonna be very easy. Okay, I'm not kidding. It's gonna be very easy. As we do the exercise later, right, you will notice that why every exercise they ask the things all same one, because the amount of things that they can ask is actually very limited since there's so little topics. Okay, so I believe for your first exam, which is most of your, this is your first exam, right? Okay, your midterm, I believe it will be very easy for you to score A. Okay or not? Can or not? Yeah, can score A or not for this first exam? Everyone. Easy, Okay, can score, all right. Why you give me the face like that? Maybe, okay, can one, yeah, no problem. Okay, I will explain to you, probably B, because of essay lah. No lah, later you'll see very easy one. Okay, I'll explain to you what is inside the notes first. So from page number 1 to number 4 is just short notes for you. So when you need it, you just read lah, okay? Now we're gonna do from page number 5 onwards today. Okay, so page number 5, you see there's question 1, question 2, question 3, question 4, question 5, question 6, question 7, question 8. Okay, right? This is what we're gonna be trying to do today. Now, we have 2 hours, right? You guess how many questions we did just now in the Mandarin class? How many questions we did in the Mandarin class just now? 4 questions. Wow, exactly. Very good. Yes, we did 4 questions in 2 hours. I tell you, 2 hours time, very fast one. Okay, little bit, then finish already. Yeah, we just do 4 questions, then we're done already. So if there's any specific question you want me to discuss, for example, like you think, teacher, I think I really need to do the motion graph. Can you teach me how to draw motion graph or not? Or teacher, I think I really need to do on ticker tape. Or teacher, I really need to do on this impulsive force. Yeah, then you let me know lah. Okay, right? Then I'll try to cater to you all lah. Okay. Now, from page number 21 onwards, you can see this title midterm exam revision question. This one is an extra question for you lah. Basically, it's a whole set of questions. Total, there are 13 questions plus objective questions. Okay, this one you can do it by yourself, right? We will upload the answers later on. I think maybe after today or whatever. I think you go to the website also to get the answers. Okay, yeah, go to the website to get the answers. Okay, now for those questions that I didn't do today, I will try to find some time to maybe record a video and then put it on YouTube. Okay, so if you go to my YouTube channel, right, I already have some videos uploaded there already to discuss some questions. I know I did one on gravitation also. Okay, so if you ever need to do more exercises and you want me to like guide you doing the exercises, you can always go to my YouTube channel lah, okay, and look for the videos there. All right. Okay, so any questions or not before we start? Any questions? Anything you want me to cover specifically for today? Any questions before we start? Any requests? No? Okay, all good? Okay, then we start already. So we start from question number 1. So page number 5, question number 1. Okay, let's begin. I'm recording already, right? Okay, yes. All right, so here we have a little boy, okay, and this boy is playing a skateboard. Now, here you can see 3 of these boys, right? They are all the same person, but this is his location at different times. So you can see here t equals to 0 second, 2 seconds, and 5 seconds. So let's say at the start, I take a picture, the boy is here. After 2 seconds, I take a photo, the boy is here. After 5 seconds, I take a photo, the boy is here. Okay, so this is the location of the boy at different times lah, basically. Okay, now Calculate, based on diagram 2.7, calculate the boy's acceleration from A to B. Okay, how to calculate the boy's acceleration from A to B? Now, you want to calculate acceleration, right? You're going to need a formula to calculate. If I open the formula sheet, by the way, this is the formula sheet that you will get if you use the government's paper, right? If let's say your school uses the government's test paper, you will get something that looks like this. Now, if you during SPM, you also get something that looks like this. But if your school creates their own papers, then I cannot guarantee you lah, huh? Okay, cannot guarantee. Now, let's look at this formula sheet here. Can you tell me, is there a formula for acceleration or not? Do you see a formula for acceleration or not? Gonna acceleration. Yes, no? No, right? There's no formula for acceleration, right? No A equals to something, something, right? So the way you need to do from the acceleration, right, is you get it from this equation, this first Suvat equation, right? You're going to move these things around until you get A is equals to something, okay? So let's say I move the U over to the other side to become minus V minus U equals to AT. Then I move the T to the other side to become divide. So V minus U divided by T equals to A. Okay, any questions on this? Yeah, so this is how I get my formula for acceleration. I'm going to write it down. A equals to V minus U divided by T. So V is final velocity, U is initial velocity. From A to B, the final is 2, the initial is 0. Divided by the time. Time from 0 to 2 is 2 seconds. So A is 1 meter per second squared. All right, the units for acceleration, meters per second squared. Okay, next one, calculate the boy's acceleration from B to C. So same thing, A equals to V minus U over T. Final velocity is 3.5 minus initial velocity is 2 divided by, now the time, don't go and write 5. The time is a time taken from B to C. You don't go and write 5. It's supposed to be from 2 to 5 is 3 seconds. Okay? So you put 3 seconds. All right? 3. So this is 1.5 divided by 3, which is 0.5 lah. Okay? 0.5. Can I? First, let me stand up first. My stomach too big already. Okay, next question. Calculate the displacement of the boy from B to C. Displacement means I want to find S. Okay, if you look at the formula sheet, got formula to find S, right? Got one here, got one here. And both of these are what? Both of these are Suvat equations, okay? So it's very obvious that they want you to do a Suvat formula. So you do SUVAT, okay, right? And then you want to find displacement. You are trying to find S, so you put a question mark here. The initial and the final from B to C, just now we already did already. Initial is 2, final is 3.5. Now, the acceleration you got or not? Acceleration you got 0.5 ma, you calculated. And then the T, the time from B to C is 3 seconds, okay? Now, you literally have all the information already. Okay, you have all the information already. But I wouldn't suggest you use the A. Why? Because this A is something that you have calculated. And during an exam, you cannot know for sure whether you are correct or not, right? So you might have calculated this wrongly. You won't know. So I won't suggest you to use your number. unless you absolutely have to. Unless you really got no other choice already, you must use this number. But now, I can actually just use U, V, and T, which are all the numbers they gave me already, and then find S. Okay, understand? So I don't use the A. Okay, so we choose the formula with S, U, V, and T, which is a formula with S, U, V, and T. S, U, V, T. No A. This one, right? This one, so I'm just going to copy the formula down. S equals to U plus V divided by 2 times T, 2 plus 3.5 divided by 2. Okay, come, give me your answer, so that I can compare them with each other. Otherwise, we don't know whether it's correct or not. Okay, anyone else got 8.25? Is that the correct answer or not? Okay, yes, 8.25, all right. All right. The units is meter because displacement means how far. Okay, displacement means the distance that you travel. Okay, next one. Diagram 11.3 shows a girl wearing a helmet and safety pads while playing on a skateboard. Explain why the girl needs to wear the helmet and the safety pad. Okay, so this is an explanation question. I would say about 3 to 4 marks this question. Okay, now how do you explain why the girl need to wear the helmet and safety pad? You don't tell me, oh, so that the girl won't get hurt, lor. Cannot. Not good enough. Okay? How would you explain how does the helmet and the safety pad like why does it help? So she don't die. Again, you can say so she don't die, but how? How to prevent her from dying? That's the point. How to prevent. Okay, someone mentioned increase the impact time. Okay, what else? What else can we mention? Besides increase the impact time? Besides that? Increase impact time, so what? So what if we increase the impact time? Okay, very good. Reduce the impulsive force. Okay, so you got to explain to them why does the helmet or the safety pad increase the impact time and then reduce the impulsive force? So why? So you say because inside the helmet and inside the safety pad, we have what? Inside the helmet or inside the safety pad, we have what? What kind of like thing causes it to increase the impact time and reduce impulsive force? Very good. Padding or soft padding. Exactly. You see, why cannot get A like that? Why cannot get A? Yeah, you all know what? You all know exactly what you need to write. So you say the helmet. Wait. The helmet and safety pad has soft padding. Okay, this will increase the impact time. Okay, this will increase the impact time when the girl falls. Okay, and then this results, or you can just continue to say this will decrease the impulsive force. Okay, this will decrease the impulsive force. Therefore, the girl does not get injured easily. Okay, now, is it something that you think you can write it out? Yeah? All I just need from you is these keywords only. The keywords that you all give me. Increase impact time, reduce impulsive force, got padding, okay? Then you can try to form every sentence. You just write down, oh, okay, how do I say the padding? How do I say the impact time? How do I say the impulsive force? Then you're done already. Easy, right? Yeah? Yeah. It does give marks also. Yeah, because they say explain why she need to wear ma. If she say explain why the girl does not get injured easily, then of course this one got no marks because we already know she does not get injured easily. But now they just say why you need to wear. So in the end is does not get easily. Does not get injured easily. Then you explain why because less impulsive force. Then you explain why because longer impact time. Then you explain why because helmet and safety pack got soft padding. Okay? That's how you get the marks lah. Okay, sure. All right, so I'm gonna go on to the next question. Okay. Now, here we have a sprinter. A sprinter is someone that can run very fast, but only for a very short distance only lah. Okay? It's not like a marathon runner. Marathon, he can run for a long time. This sprinter can only run for a short time only, but he can very quick burst. He can release a lot of energy in that short time. Okay. The man should wear proper attire. Attire meaning the clothes lah, okay? And shoes, and use any additional equipment to make him run faster, okay? And achieve maximum acceleration. So can you tell me what kind of attire should the man be wearing? I'm sure you all know this. I'm sure you all know what to answer. What kind of attire should the man be wearing? Pants only. Why leh? Why pants only leh? Why not just don't wear anything? Why not just don't wear anything? Because the penis will shake here, shake there, is it? Yeah, then cannot run properly. Yeah, his penis will like like that. No. Tightly fitted clothing. Okay, that's one. That's one. Tightly fitted clothing. Okay, and then what else? Anything else? Uh, not like sports attire. Okay, what is good about sports attire lah? You can say like that. I want the characteristic of the attire, not like the type of attire. I want the characteristics. So like tight attire is one. Okay, besides thin leh, thin like because thin maybe okay, it's good for you because you don't get hot. But I want something that can help you run faster, maximum acceleration. Besides thin, besides tight. What else? Light ma, correct or not? Lightweight clothes. Yeah, that's another one that you can say lah. Okay, so you can say tight fitting attire. Okay, or you could also say light attire. Now, benefit of tight fitting attire, so you look sexier, you gain more confidence, you run faster. Correct or not? Yeah, the sexier you are, the faster you can run. Now is to reduce air resistance. Okay, you don't want when you run then the air be like pulling your shirt like that. Okay, then you become very slow. All right. Now light attire, don't say can run faster. Okay? Don't say greater velocity, don't say greater speed. Light doesn't mean you can go faster. Light means you can accelerate faster. Okay? You can reach the speed faster, but doesn't mean you can always go very, very fast one. Okay? Heavy things also can go very, very fast, but they take a very long time. Okay? So don't say greater speed or greater velocity. You can only say greater acceleration. Okay? Greater acceleration. Okay, now tell me what kind of shoes should he be wearing? What kind of shoes can help him run faster or accelerate more? Okay, can. What else? What else? Okay, very good. Very good. Everyone thinking of spikes, right? Yes, you must have spiked shoes. Okay, besides that, yeah, you can also say lightweight. No problem. No problem. So, spiked shoes. Either you write spiked shoes or you write shoes with spikes. Also can. Okay? Spiked shoes or shoes with spikes. Okay, the reason is so that you can have better grip. Okay? The spikes, they can go into the ground and then give you a better grip. Now, if you want to write light shoes, also can. Again, same thing is greater acceleration. Okay, greater acceleration. Okay, next one. Now, this one, I'm not sure whether you all know or not. So I'm just going to tell you all. Okay? Carbon plated shoes. Why you want carbon plated shoes? Carbon not always good one or carbon not everything. Greater energy return. Why you need? I don't need energy return. I want to just like have the maximum burst so I can just run the fastest only. No need energy return, no need anything like that one. I just want the maximum burst so that I can go the fastest in this 100 meters. Yeah. Okay, so this one is basically the best you can get really lah. Okay. All right. Now, additional equipment, I don't know whether you all know this or not, but if you ever see like people running, okay, they always have this thing at the back one. Oh, 100 plus. 100 plus is additional equipment. Wow, very good. Milo also can. You can say Milo also. Milo is what is the slogan for Milo? Something about champion, right? Something like unleash a champion or something. Milo and 100 plus. Okay, so you see people when they run, right? They have this starting block at the back. I don't know whether you noticed this before lah. Okay, next time when you watch Olympic, you pay attention. Actually, I also don't know Olympic or not. Okay, so why do they have this thing behind, right? Is so that whenever you run, the first push of your leg, when you first push your leg, right? For us normal people, if you just put your leg on the ground, when I push, where do I go? I go up. Correct or not? Then you're wasting your energy already. Why you want to waste your energy to go up? You want to use your energy to go forward. So if I can put my legs like this, like vertically, like in the picture, then when I push my leg, right, I will be pushing myself in front instead of pushing myself up. So that's what the starting blocks are for. Okay, in order to help me give more boost. Okay, give more boost at the start. So you can say use starting blocks. Okay, use starting blocks. Now, the reason you can say produce produce greater forward thrust. You all know what's forward thrust or not? Thrust is any force that push you forward. Yeah, anything that push you forward is called thrust. It's a force. Yeah, it's a forward force. Produce greater forward thrust during the start. Okay, produce greater forward thrust during the start. Okay. Next, if the man reached the finishing line in 10.2 seconds, calculate the acceleration of the man. So, of course, if you want the acceleration, you can also use A equals to V minus U over T. But then you have to check lah. Do you have your U and V or not? You got the initial speed, which is 0. At the start, you are surely 0, 1. Okay? So your U is 0. But you don't have your V, you know. They never give you the final speed. So you cannot be using this already because they never give you the V. So you have to find another way. You have to use another Suvat equation. So I'm trying to find acceleration. The distance that I'm running, S, the distance that I'm running is 100 meters. Okay, 100-meter run. T time 10.2 seconds. Okay, so I'm going to give you the formula. S equals to UT plus half AT squared. Substitute everything inside and give me an acceleration. Give me an acceleration. Have you ever drank this sparkling Red Bull? Have you ever drank sparkling Red Bull? It's like if you go to Sunway Pyramid and you spend more than 50 ringgit, they give you 6 cans of this for free. Yesterday I went and redeemed. Yeah, you just have to spend more than 50 ringgit a day, which, to be honest, everything also more than 50 ringgit a day now. Hey, Pastor, can get your acceleration or not? Okay, I have one answer, 1.92. Anyone else? I have a 1.92 here. Okay, I have another 1.92, so that confirm the answer. 1.92 meters per second squared acceleration. Oh, it's 1.92233. Okay, then 1.9. Let me write one more lah. 1.922 lah. Okay, 1.922 meter per second square. Yeah. If you cannot get the answer, please let me know, so I can show you, okay, how to get it. All right, shall we go to question number 2? Okay, question number 2 is about momentum because I already see the word momentum here already. So we have a space vehicle here drawn for you. Space vehicle moving at 0.5 meter per second, about to dock with the space probe moving in the opposite direction. You know what's dock or not? Dock basically means parking. Okay, parking, right? Like, oh, dock the ship means you park the ship. Okay, like parking the car like that. So he wants to park on top of this thing, basically like that, connect together. Yeah. The mass of the space vehicle and space probe are 2,500 kg and 1,500 kg respectively. Okay, so space vehicle is this guy. This is 2,500 kg. Okay, and then space probe is the other one. That's 1,500 kg. Okay, after the docking procedure, the space vehicle and space probe move together at 0.2 meters per second in the original direction of the space vehicle as shown in diagram 4.2. This is after they connect together. They both move at 0.2 to the right. What is the collision that occurs in diagram 4.2? Now we have three types of collision. We have elastic. Elastic meaning like it's bouncy. Okay? When you have two things bang together, if you can make the sound effect toing, toing, toing like that, that means it's elastic already. Okay? So whenever you hit and then you separate, it's elastic. If you hit and you don't separate, if you hit and you stay together, that is inelastic. That is what's going on here lah. Okay, they hit and then they stick together. This is inelastic collision. Okay, now one more type of collision is called explosion. It happens when two things are originally together and then suddenly, boom, they separate. Okay, that's explosion. Okay, now, based on the information provided, calculate the total momentum of the system. Okay, let me tell you something. In your formula sheet, right, you don't get any special formula for momentum one, you know. You don't get whatever M1, U1, V1, U2, M3, V3, V4, father, whatever, don't have. There's only one formula for momentum, which is mass times velocity. That's the formula for, you know, momentum. So don't expect they will give you like any special formula like what is total momentum. No, you have to understand yourself. The meaning of total momentum means your momentum plus your momentum plus your momentum plus your momentum. That's total momentum. Okay? So you want to get the momentum of these two people, you have to add their momentum together. So the total momentum, you just add the first person's momentum, which is mass times velocity, plus the second person's momentum, mass times velocity. Okay, this one is for the space vehicle, this one is for the space probe. All right, now if you look at it, right, you got the mass of the space vehicle, that's 2,500. You have the velocity of the space vehicle at 0.5. You got the mass of the space probe at 1,005, but you don't have the speed of the space probe. Right? So what then? So what now if you cannot find the V? Because you don't have this, you cannot find total momentum. But never mind. You just have to look at this. Look at the after. Look at the second diagram. You see, the mass of this space vehicle is the same, 2,500. The velocity of this space vehicle is this, 0.2, plus the mass of this space probe is 1,500. And then the velocity of this space probe is also 0.2. Because they move together, right? They move together, so their velocity must be the same one. So this is 0.2. Okay, so can you calculate what is the total momentum for me? Okay, I have one 800 here. I have an 800. Anyone else confirm this answer? 800? Okay. All right, thank you. Now, here's a real question. What's the units for momentum? This is a real question. What's the unit for momentum? Any ideas? Anna? No, 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 no. Okay, all right. 10. So it is kg ms negative 1. Okay, all right, later I explain that. All right, kg comes from mass and meter per second comes from velocity. I'm just combining these two people's units together only. Okay, is that ns? Actually, it is. Actually, it is Newton second because Newton is kg ms negative 2. All right, yeah, so it is Newton second, but we normally use this instead lah, right? We rarely will use ns1. Okay, all right, now someone asked, teacher, I thought need to convert kg to gram first. Actually, no, because our SI unit for mass is kg. Gram, you have to change to kg. Okay, if it's 800 gram, you have to change to 0.8 kg. Yeah, so our SI unit is kilograms for mass. Okay, time will be seconds, distance will be meters. Yeah. Now, what is the speed of the space probe before docking with the space vehicle? So the speed of this guy before docking is this, the thing that I was missing just now, correct or not? Just now, I didn't have this thing, right? If I write back down the same thing, if I write back the same thing, just now, I didn't have this. Sorry, not MU, MV. Okay, I didn't have this. But what's the difference now? Now, I have this already. I know this total momentum is 800 already. So if I use back just now what I wanted to do just now, 2,500 times 0.5, and then plus 1,500 times unknown. Okay, so now you can get what is the initial speed already, because now I already know the total momentum. Okay, you give me the V, and don't worry if it's a negative number, you are supposed to get a negative number because originally this guy was moving in the opposite direction. You are supposed to get a negative velocity one. Is it negative 0.3? Is it negative 0.3? Oh no. Oh, getting some bad feelings here. Why nobody there to confirm your answer? Okay, negative 0.3 confirm. All right. Negative 0.3 meters per second. Okay? Negative 0.3 meters per second. Yeah? So actually, when you do the calculation, you need to be very, very sure that the directions you got checked. Okay? If let's say I was supposed to do this first, then I must put a negative here now. Whatever this number is, I supposed to put a negative here. If let's say I were to do this thing first lah. Because opposite direction, velocity got direction one. Okay? Now, what gave me who gave me permission to take this 800 and make it same as this? Because when I did this one, right, I was using the after collide. But when I do this one, I'm doing the before collide. So who gave me the permission to make the total momentum same? So there's this thing called the principle. What's the word? Principle of what? Principle of what? Yes, very good. Conservation. Okay? Conservation means must be the same, must always remain the same. Conserve what? What are we talking about? What is the same? The momentum same, no? So principle of conservation of momentum. Okay? Conservation of energy is another principle, but it's also a real principle. It's also real. But it's just not for this topic lah. This one we're talking about momentum only. Okay, so what does this principle say, right? You can say the total momentum before collision and the total momentum after collision must be the same, must be equal. Okay? Total momentum before collision and after collision must be equal or must remain the same. Hey, do you remember how to explain how a rocket works or not? How many times I taught you this already? Yeah? How many times I asked you to copy that paragraph? The paragraph that will always get you full marks one. All you got to do is change the object and you're going to change the direction only. Yeah, remember that? Okay, so first of all, you tell me first, what does a rocket shoot out? What does a rocket shoot out? Yeah, the rocket don't shoot out fire, nah. You don't say the rocket shoots out fire, The rocket shoots out hot gas, correct? Okay, so this hot gas, right? It's up to you. The first one is optional. It's up to you whether you want to tell them where does the hot gas come from or not. Okay? You could always add a sentence in front one and say, oh, the hot gas is because there's combustion. Yeah, but that's totally optional lah. Because other questions you don't have to explain them. For example, if you shoot a bullet, you want to explain why the gun fly back. Do you need to explain where does the bullet, like why does the bullet move? No need ma. If let's say I want to talk about the squid shoot the ink. Do you need to explain how the squid produce the ink? No need ma. So this is optional lah. So if you want, you can add and say combustion in the rocket produces hot gas. Okay? Now, for the key part. Okay, everything after this, I told you already, it's all usable for any question one. You just got to change the few words only. So first of all, you say, this hot gas needs to go where? This hot gas needs to go down. So hot gas moves downwards. But that's not enough. You can't just say the hot gas move downwards. You must say the hot gas move downwards at high velocity. Why is that? Why do I need to say that the hot gas moves very quickly? Why cannot move slowly leh? Why must move with high velocity leh? So that I can do what? So that I can produce what? Why the hot gas must move at high velocity? Yes, correct. It's so that you can produce a very, very high momentum. This produces a large downwards momentum. Okay? This produces a large downwards momentum. Okay, then according to POCOM, this POCOM not for you to buy golden, this is Principle of Conservation of Momentum, POCOM, POCOM. According to POCOM, there must be an equal but opposite reaction. Okay, so basically the principle of conservation of momentum. Oh, cannot write in exam, cannot write POCOM. No. In exam must write the full word. Must write the full word. Okay, so basically according to this principle of conservation of momentum, right? If something go up, something must go down. If something go left, something must go right. If something go forward, something must go backwards. That is the law. Okay, so there must be equal but opposite. You can even say what? Equal but opposite upwards momentum if you want. Okay, because you already know that one was downwards, so the equal but opposite is upwards momentum. So therefore, the rocket moves upwards. Okay, the rocket got no choice but to go up. Okay. Yeah, so I can use this for anything. Let's say I want to explain why when I fire a gun, the gun will always move backwards because the bullet moves forwards at high velocity. This produces a large forwards momentum. According to principle of conservation of momentum, there must be an equal but opposite backwards momentum. Therefore, the gun moves backwards. Okay, any example for momentum explanation you can use. Always will get 4 marks. Ngam ngaman. Okay, understand? Anyone still copying this? Anyone still copying? Okay, done. All right, let's go on to the next portion. You write this, you get full marks every time, correct? Of course, you must write the correct thing lah. You don't the thing ask for rocket, then you talk about jet engine, then wrong lah. You must write the correct object and you must write the correct direction. But you follow this exactly right, no problem one. Okay, you follow this format, you will surely get full marks. Okay, all right, now next one. The diagram below shows a water rocket made by a student. So water rocket is similar to rocket, but this one shoot water lah. Okay. And you need to modify the water rocket lah based on this, whatever, all these different things lah. Okay. And then you want it to travel the maximum horizontal distance. Okay. Horizontal distance. All right, now first one, material. Can you tell me what kind of material do I want for my rocket? What kind of material do I want? Again, no name of material. I don't want the name. I want the characteristics. I want the type. What kind of material? Solid ah. Glass also solid ma. Ah, right. Solid not good enough. Another word. Okay, light material. Let's say I don't want to write light material. Let's say I want light to be my reason. So like, what kind of material should I use so that the reason is it is light? What kind of material should I use so that the reason is it is light? Also, just now who worry about essay one? Now is your chance already. Come on, come on. What kind of material should I use? No, no, no. I don't want the name of the material. I don't want the name of the material. Again, let's say I don't want it, I don't want to say like, I don't want to say light material. I don't want to say light material. Instead, I want something material. Okay, yeah. So that the reason is, oh, I choose it because it is light. Yeah, I want that to be my reason. So it should be low watt. A material that is low watt so that it is light. You see this word a lot one in essay question. You see this word a lot one. Yes, very good. Low density, correct. Low density material. Okay, besides low density material, if I don't want it to break so easily, yeah, I don't want it to break so easily because when you spray the water, it's very, very strong one. So I need the material to be not solid, but strong, correct. Not hard, yeah? I want it to be strong. Hard and strong is two different things, okay? So either you say strong material or you say low density material. Okay, so if you put strong, doesn't low density make it not strong? No, because low density, right, actually just means mass and volume. Okay, yeah, density is mass and volume. So the strength of the material doesn't depend on these two things. Yeah, strength of material doesn't depend on these two things. Because we have something like carbon fiber. Carbon fiber is super strong, but it's super light. So it's low density. But then it's very strong also. Yeah. So strong material, you can say either you can say it's durable, you can say it does not break easily. Okay, and as for low density material, you can say because it is lightweight. Okay, you can say can fly higher, you can say greater acceleration. Yeah, anything that's logical lah. Anything that's logical. If you're wondering, oh, teacher, can I write like that or not? You can ask now lah, huh? Okay, then I can let you know whether it's suitable or not. Okay, number two, the shape of the rocket. I want my rocket to look like what shape? There's a very specific word that I'm looking for. There's a very specific word that I'm looking for. This kind of shape makes it go faster, fly higher. What is that shape? Not cone, not pencil, but you know what I'm talking about. Yeah, front sharp, like that. Okay, correct. For the rest of you, do you still want to try to guess? Starts with the word arrow. The bullet train is also this word. Bullet train shape is also this word. Arrow something. Arrow. Like that. Aerodynamic. Okay, yeah. I want you to put this word inside your head. Yeah, just add this word into your dictionary because you're gonna use this word so many times. Okay, in physics. It's a wrong arrow, correct? Yeah, but let me tell you, you are not the only person that wrote arrowhead. Yeah, You're not the only person that wrote Arrowhead. Let me tell you. There are other people that wrote Arrowhead as well. Okay? So yeah. So I wouldn't say you are completely wrong because other people thought of the same thing also. Okay, so yeah, this word you must remember because like jet plane or like bullet train or like sports car, they are all this shape so that the air can just fly past. Okay, the air can fly past. So aerodynamic shape is to reduce air resistance. Where's my aircon remote? Oh, aerodynamic shape to reduce air resistance. Sun is so bright outside, no wonder it's so hot. Just now, some more raining. Wow. Yeah, for people in the Klang Valley, you all will know. Just now it was raining, sky was very dark, then suddenly the sun just came up. Okay, third one, angle of launching. Now, angle of launching depends on where you want it to go. If you want it to go up high, the highest height, of course, you got to launch it straight up lah. You got to shoot it straight up. But right now, I want it to go the maximum horizontal distance. So how should I launch the rocket? If I want it to go the maximum horizontal distance, do I launch it like this, lying on the ground? Do I launch it horizontally like this? Since if you want it to go maximum height, then you should launch up. Then if I want maximum horizontal distance, then should I launch it like that? What's wrong with launching it like that? Why I cannot launch like horizontally to get the maximum horizontal distance? Exactly. The ground slows it down. Yeah. The ground will have some friction. It will basically tumble along the ground and then it'll just stop very quickly. Okay. So if you shoot it upright, at least he will have some time to travel and then fall down. Okay. Now, going straight up will go up and then come down. If you go sing it a little bit, it'll go up like that and then come down here. If you go too horizontal, then it also drop down very quickly. So 45 degrees is the way to go because it's a perfect balance of up and horizontal. Up is so that he doesn't land on the ground so quickly. Horizontal is so that he can basically travel horizontally. Okay? Yeah. So 45 degrees is the perfect balance of height and distance. Okay? So you can say launch at 45 degrees. Okay? Launch at 45 degrees angle. You can say the rocket can travel maximum horizontal distance. Okay? The rocket can travel maximum horizontal distance. Okay, next one. Volume of water in the rocket. How much water should I put in the rocket? How much of the bottle should I fill up with water? How much? Try to guess. Any of you actually did the water rocket in school or not? Any of you actually got make a water rocket in school? No Alright, so sad. I remember got one school got do water rocket before, but I'm not sure which school got. I forgot which one already. So how much water should I put in? Whole bottle, full bottle, three quarters, three quarters. Why not full bottle? Why not full bottle? If you're gonna put three quarters anyway, why not just put the whole bottle water? Not pressure. Okay, yes, it's too heavy, correct. If I fill the whole bottle with water, it's gonna be too heavy for it to fly. Then why not just put like 1/4? Why not just put like 1/4 of water? Just add any, just a little bit. Why too less? Not because unstable. It's not unstable. But why is it too little? Why too little water cannot work? Very good. Not enough momentum. You remember, the rocket needs to shoot hot gas. So the water rocket needs to shoot water. If you don't shoot water down, you cannot fly up. If you don't have enough water to throw away, you cannot fly up also. So you need enough water to throw out. But you cannot have too much water also, otherwise you'll be too heavy. So if you write 1/3 can, half also can, but only around like that only. Okay, either 1/3 or half only. Yeah, 1/3 of total volume or half. Okay, so that the rocket can produce large momentum without being too heavy. Okay, the rocket can produce a large downwards momentum because you can shoot the water up, but you are not too heavy. Okay, and the last one, what can I add to the water? Add to the water pula. No, you don't add anything to the water. That one is cheating. What can I add to the bottle, to the rocket? What are these things called? What are these things called? Add a jet engine to the rocket? Can. Of course can. If you add jet engine to your water rocket, I'm pretty sure you will be the winner lah. And then I think your school will give you scholarship also lah. If you can make your own jet engine at home, I'm pretty sure they'll give you a scholarship also. Okay, what are these things called? These things. Like the fish, they have this thing also. Correct. These are the fins. Okay, these are fins. Add fins to the rocket. You know what the fins are for? Do you know what the fins are for? Like, what are the fins on the fish for? Do you know? They're actually the same purpose, you know? It's the same purpose one. Why the fish need to have fins and why the rocket need to have fins also. So what? Two? No. The fins add air resistance actually. Anything extra you add is extra air resistance. So it's not lower air resistance. Actually, it's to keep the rocket stable during flight. Okay? Hello? Fishes don't use their fins to breathe. Fish use their gills to breathe. The fin is that one and the one behind up there. Like the shark fin, that one is fin. Okay, it's to keep it stable. You try to take a water bottle and you try to throw straight up. It will never maintain like that one. It will always try to bloop, fall down like that one. You throw up, it will fall down like that. You throw up, it will fall down like that. Okay? So they need the fin to actually make sure they are always like straight like that. So fish also. If the fish they got no fins the fish will like whoop, flip over one, you know. Okay, they cannot actually swim properly one. So the fins is to make sure they always maintain straight like that. Yeah. Okay, so we're gonna take a short break, 5 minutes. Yeah, so that I can go and pee. Okay, so we will come back at 3:18 now 3:13 5 minutes 3:18 we come back okay, and then we continue. All right. You want to go pee, go pee. You want to go drink water, you go drink water. You want to go drink or pee, also can. Okay? All right, bye-bye. Hello. Okay, I'm back. Are you back? Who's not back yet? Please raise up your hands. If you're not back, please raise up your hands. Okay, all back already, All right, very good, very good. Okay, now let's continue with this question number 3. Okay. Now, I have a child and an adult sitting on similar swings shown in diagram 2. State Newton's first law of motion. Okay, Newton's first law of motion says what? Newton's first law of motion says that if something is not moving, what will happen to the object? If there is something that is not moving, then the object will continue to do what? Continue to not move lah. Right now, yeah, continue to remain stationary lah. Okay. Now, if the object is already moving, then what will happen to the object? If the object is already moving, then it will continue to move forever and ever and ever. Understand or not? Okay. Now, this thing, right? Okay, you can write it like this. You can say an object will an object will do what? An object will remain. Okay, now stationary is one of the ways you can say it. Remain at rest is another way you can say it. Okay, so an object will remain stationary or remain at rest. Okay, or remain what? Or it can remain moving with uniform speed. Okay, it can remain moving with uniform velocity. Okay, unless what happened? Yes, correct. Unless there is another force come and kacau him. So unless acted on or acted upon by an external force. Okay, means got another outside force come and kacau. Then only it will change basically. Okay, unless acted on by an external force. Okay, now if both of this child and the adult, they are given the same push, who is more difficult to move? They are both not moving yet. Yeah, they are just both sitting on the swing only. Who is more difficult to move? Who is more difficult to move? Adult not the small kid The adult you can say, hey, you swing yourself lah, then move already ma. You see, I can voice control. Voice control easier ma, right? The adult you just say, nah, you just swing yourself. Okay? Then the kid you have to actually move yourself. No, still the adult Okay? So the adult is harder to move. Okay, then who is harder to stop? Who is harder to stop? Don't get cheated by the question, okay? Don't think just because, just now the first answer is adult, then the second one must be child. No, the answer is still the adult. The adult is still harder to stop, okay? Remember, I gave you the example of the lorry and the bicycle. If the lorry and the bicycle are both moving towards you, the lorry is harder to stop. But if the lorry and the bicycle are both not moving, then the lorry is harder to move also. Okay, remember why or not? Because of something called what? This is because of what? Something called what? Yeah, something called inertia. Remember, the lorry, he's like that one. He's, I don't want to move. I don't want to stop. Okay, so whatever you ask him to do, he also don't want. Because he want to do whatever he's doing right now. He want to maintain. Okay, so the adult is also like that. I don't want to swing. And then when he swing already, he said, I don't want to stop. Okay, but the kid is like, I don't want to swing. Oh, you push me, then I swing already. Okay, so adult is harder to stop and harder to move because the adult has greater mass, so he has greater inertia. Okay? The adult has greater mass, so he has greater inertia. Make sense or not? Yeah. Now, next one. This is an experiment with a hacksaw blade. Hacksaw blade is like a metal ruler lah. Yeah, you just imagine it is like a metal ruler, and then you stick a piece of plasticine at the end of the metal ruler. Okay. Now when I swing it, I just pull and then I let go because the metal ruler will go doing 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 like that ma. The plasticine, right, will actually cause it to like change to vibrate differently lah. Okay. So the one with the 50-gram mass, you can see the period. Period means time taken for one oscillation. So that means toing is one oscillation. The toing is how long? Okay. So 1 second means every second toing, 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 toing. But this one with the heavier one, right? This one, the period is 2 seconds. That means it's like that. Toing, 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 like that. So it's a bit slower, right? So when oscillated, both hacksaw blades oscillate with different periods of oscillation. Take the correct answer. Period of oscillation is a scalar or vector quantity. Do you all still remember what is scalar and vector? Remember or not? What's the difference between scalar and vector? One of it got what and the other one don't have what? What's the main difference? Whether it has... No, both also got magnitude. Magnitude means the amount. Both also got number one. Scalar also got number, vector also got number. But vector got what? And then scalar don't have. Vector got something that scalar don't have one. Vector got? Don't remember? Hey, anyone? Direction, correct. This one, chapter 1, exam will come out. Chapter 1 exam will ask vector got direction, which means it has plus and minus. Okay? Scalar don't have direction one. Scalar only got number only. All right? So, period is a scalar because time cannot have direction. Time is always moving in one direction only. Okay? So time cannot have negative one. Yeah? Okay. Next, based on the diagram 11.1 and 11.2, contrast the mass of the two plasticine balls used. Contrast means compare. Okay? Contrast means compare. Yeah, so you just treat it as a normal compare question. The mass in diagram 1.1 is 50 grams. The mass in diagram 1.2 is 200 grams. So you can say mass of plasticine in diagram 1.2 is greater than 1.1. Okay? Now, of course, you can always say 1.1 is smaller than 1.2. Okay? Yeah, but greater is quite easy to say lah. Yeah, greater is you confirm is surely correct on this word. Okay, no need to worry about like taller or longer or higher, which one can use. No, just always use greater only. Then you'll be correct already. Okay, next. Based on diagram 1.1 and 1.2, contrast or compare the period of oscillation. Period for diagram 1.2 is 2 seconds. Period for diagram 1.1 is 1 second. So period of oscillation in diagram 1.2 is greater than 1.1. Yeah. Next one, state the physics concept involved in answer above. We already know already. We are talking about inertia. Okay. Next one. The property in which a body resists change from states of rest or motion is known as inertia. Based on diagram in B, blah, 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 state the relationship between the inertia and mass. Okay. So we know that the greater the inertia, the greater the mass, right? Yeah. So you just write lah. Hey, sorry, the greater the mass, the greater the inertia. You don't write the opposite way, Don't write the opposite way because the mass affects the inertia, not the other way around. So the greater the mass, the greater the inertia. Like that. Okay, next. Why does a super tanker, you know what super tanker or not? Super tanker is the big ship that carries a lot of things and a very heavy ship. Why must it stop its engine very far, even though it haven't reached the port yet, even though it haven't reached the land yet? It must stop the engine already. Because again, big mass, big inertia, harder to stop. Okay, you must mention it's harder to stop lah because of the inertia. So you say the super tanker has a large mass. Okay, then you say the effect of inertia causes it to be harder to stop. Okay, the effect of inertia causes it to be harder to stop. Okay, easy, right? Yeah, and you notice the whole question asking the same thing again and again and again and again. Okay. All right, now another essay question. So we have a petrol tanker truck, this one from Shell, okay? Suggests a safety design of the loaded truck to transport fuel safely. Your answer should be based on the following aspects. Okay, number one. Okay, if we have essay, do we do table? It's one of the options. Okay, it's one of the options. The table is up to you one, right? So you can write table. So just draw exactly like this, and then you do characteristics on one side, and then you do reason on the other side. Okay. Another way is, of course, you can just write short paragraph. You say the tanker should have what? This is because blah 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 blah. Then the next one, the tanker should have what? This is because blah 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 blah. The tanker should have this. This is because blah blah blah. Okay, this is another method for you to do. So these two methods is entirely up to you. Yeah, whichever one you are more comfortable with. All right. If you're too lazy to draw table, then you write short paragraph. If you think you don't want to write so many words, then you draw table. Okay, yeah. So both also acceptable. All right, what can you tell me about the compartment of the lorry? This one. What can you tell me about how should you design this tank? Give me some ideas to design the tank so that it is safer. Okay, so divide into different section lah, huh? Is it correct? Yeah. So you can say divide the tank into multiple compartments. Or you can say divide the tank into multiple sections. You can say add dividers inside the tank. Anything that says what we're trying to say lah. Okay. Now the reason is because, right, when you split the field into smaller groups, then the effect of inertia is not so much. Okay. Every small portion of field, when they hit the wall, they be like, "Aya," like that. But instead, if let's say you don't have a divider, then the whole thing is one big liquid. Then when it hit the wall, it'll be like, oh, like that. Okay. So you have to divide it to smaller compartments. So you can say reduce the effect of inertia. Okay. Reduce the effect of inertia. Okay, next, what kind of braking system would you suggest so that the lorry can actually brake safely, especially during what? Especially during emergency braking. What kind of braking system can we have? Anyone know? I actually told you all before one. I said last time only certain cars got only. But now all cars also got this system already. Yeah, correct. It is ABS. Okay. Yeah, if you don't know how to write the full name, then you just write ABS system lah. Okay. But the full name stands for anti-lock braking system. Okay. ABS. Now, this anti-lock braking system does what? Basically, right? It helps you to stop without skidding. You know what skidding? Skidding means like you slip and then your car go like that. Yeah, basically your car will start to slide. Because if you emergency brake, then your tires will basically get pop. You just hold the tire cannot spin, then you start to slide on your tire. But the anti-lock braking system is a computer that will don't let you fully brake. Yeah, even you step the pedal until maximum already, the computer will say, "Oh no, don't let him hold the tire. I let go the tire a little bit so that at least the tire can continue to spin a bit, even though you're trying to stop." Because this is better for you to control the car. Okay, you don't just lock the tire and then the tire start to slide like that. This one is better. Okay, so you can say the lorry can stop safely without skidding. Just skidding like that. Skidding means sliding. Okay. Next one. The gap between the truck and the fuel tank. So do you see there is a gap in between this tanker and the truck here? Why do we need the gap there? Should we have a bigger gap or should we have a smaller gap? And let me tell you, this is not about inertia anymore. Because if you want to prevent inertia, you got to put a piece of metal here so that the thing doesn't hit to the front. But this is about the gap. Why do I need a gap? This is more about common sense already. Less about inertia, more about common sense already. Why do I need a gap in between the head and the tail? Why leh? Why will touch leh? Prevent touching. When will it touch? When will it touch? When do I need that gap to prevent touching? Sudden stop. No, no, not because sudden stop. What else? What else? Again, like I said, it's about common sense one. You don't overthink about inertia and all that stuff. It's about common sense. Why does the lorry need to have a gap between the head and we call it a trailer. The tank is called trailer. It's the same idea as why the train cannot be one long train, but we must have few smaller train carriage instead of one long train carriage. It's the same idea one. Yeah, correct. It is easier to do what? It's easier to turn. Okay? So when your head and your body are too close together, then you cannot turn already, ma. You must turn the whole thing together already, ma. Then it's same like a whole one long train. So if you split into two, then if you have a gap, your head can turn first, then only your body turn later, right? So you can say bigger gap between truck and fuel tank so that it is easier to turn. Okay, easier to turn. All right, what else can you tell me about a lorry? Normally lorry, what else can you, what other suggestions can you give me to keep the lorry safer or to make it better for the lorry? What else can you tell me? Okay, wheels. That's a good direction. What can you tell me about the wheels? What can you tell me about the wheels? Anything about the wheels? Any ideas? What should we design? What kind of design? Like what should we add to the wheels, or what should we remove from the wheels? Cannot just say wheels, what? Right. Okay, more wheels, that's one. More wheels is one thing. Bigger wheels, okay, bigger wheels also can. Wider wheels also can, yeah, wider wheels, more wheels, bigger wheels, wider wheels, okay, yeah. Heavy duty wheels, okay, yeah, sure, can also. Okay, the pattern on the wheels, you mean the tire treads, right? The tire treads give more grip, okay, very good. So you can say a lot of things now, right? You can say use more wheels, okay? So that we can have what? We can have lesser pressure on each tire because you basically split the load already, ma. You divide the load between every wheel already, ma. So more wheels means lesser pressure for each wheel. Okay. You could also say tires with treads. Basically, the pattern is called treads, Treads. Okay, same thing like your shoes also got treads. So the tires with treads, right, is to provide more grip, but only on a slippery surface. Okay, provide more grip on a slippery surface because on a normal dry day, right, actually we don't need the treads one. The treads actually make it worse because you have lesser wheel on the ground. But when it's wet, then yes, you need the pattern because the pattern can push through the water. Okay. Now I'll give you one more. This one is specifically for fuel tanks one. Specifically for fuel tanker. You can say you want a small belt under the lorry. Okay? What is a small belt under the lorry? It could be a chain, it could be an actual belt, it's just something, right, that connects the lorry and then I just put it underneath the lorry so that it touches the ground. Any idea what this is for? Anyone knows what is this for? It needs to touch the ground and it's specifically very important for fuel tankers. You know? No. Not for balance. Not for balance. It's just like basically the lorry like that, right? Yeah. And then I can have just one thing like that. Just touching the ground. Okay, you see, fuel is dangerous because it can explode. All right. And what will cause it to explode? Fire or a spark. And you know what can cause a spark or not? Whenever you walk, and then you touch something metal, you suddenly feel the bzz. That is a spark. Because there is static, right? There's static charge on top of the lorry. As the lorry move, there's static charge here and there. So if you don't want the static charge, right, you must actually pass the charge to the ground. You must let the charge flow into the ground. Okay? So that's what the belt is for. It is to discharge the charges to prevent sparks. Okay? So next time you touch your friend, right? And you touch your friend, suddenly you shock. That shock is actually a spark, you know? That shock can actually start a fire one. It can actually start a fire. Okay, so that's why we need to try to remove as much of this static charge as possible so that it doesn't spark. Yeah. All right, let's try to finish this. One more question. Question number 4. Let's try to finish this question. Okay, I have a watermelon falling off from 2.5-meter tall table and dropping onto the floor. Oh, 2.5-meter tall table. I am not 2.5 meters. 2.5-meter tall table is like taller than me already. Okay. It drops onto the floor surface. The watermelon mass is 1.5 kg. Experience the change of momentum while falling. What is meant by free fall? So, free fall means you fall down due to what? Object falling due to what? What is causing it to fall down? What's causing him to fall down? Gravity, right? Object falling due to gravity, right? But doesn't everything fall due to gravity? Yeah, doesn't everything just fall due to gravity? Why do we specifically call this free fall? What's so special about this guy that you call it free fall instead of just normal falling? What's so special? Correct, very good. No air resistance, no external forces. So the key point here is you must say object falling due to gravity only. If you don't have the only, you might get this wrong. Yeah, you must add the word only. Okay, next, calculate the time taken for the watermelon to reach the floor. Okay, so watermelon reach the floor, time taken, Suvat question Okay, I'm not going to waste my time to tell you why is it Suvat already. Okay, S is the distance you need to fall down. So it's 2.5 meters tall. The U initial velocity is going to be 0 because before you fall down, you are not falling down. Final velocity, I don't know. Okay. Acceleration is how much? Acceleration is berapa? Acceleration. How much? 5, 10, 1.5. 9.81. Okay, 9.81 is the acceleration because this is called gravitational acceleration, accelerating due to gravity. The time taken you're trying to find, so SUAT, your formula will be S equals to UT plus half AT squared. Okay, please put in your numbers. Please put in your numbers and then find out what is T squared and then find out what is T. Okay, I only want the T only. You give me the answer for T only. 反疯了。Is the final velocity the velocity before hitting the floor? Yes, correct. Later, this question, this is final velocity. Velocity just before hitting the floor. See, got someone come kacau. Got one person come here kacau. I report to Jahan already. Let me report to Jahan. Oh, Gao Yu. Okay, come find your T. Hey, you come in, then you do. You give me an answer. Come in already, then you must do. 0.509683995 is T squared. Is it? Oh, yeah, I think. Yeah. So the 0.714, is it T? Is that T? I got 0.714 lah. If square already is, yeah, it's around 0.5 lah. You square root and see whether you get 0.714 or not. Yes, 0.714. Okay lah, then, yep. 0.714 seconds. Okay, 0.7139 lah, yeah lah, 0.714 lah. Okay, seconds. All right, now calculate the velocity of the watermelon just before hitting the floor. Okay, so this one, I do this one, same thing, but now I want V. I said already, right, just now, why I don't want to use the T, even though I already got the T, because in exam, I don't know whether this T correct or not. So I better use back the same numbers that are given to me. Okay? So find the velocity. Your formula is v squared equals to u squared plus 2as. Okay? V squared equals to u squared plus 2as. All right? U squared, 0 squared gonna disappear now. So you find v. Find v. This one should be quite easy also. Seven. Seven ngam ngam eh. 7.004. 7.004 and 7 same or not? Not same. 7.00357. Okay, so 7.004 lah. Right? MS -1. Okay, everybody got the same? 7.004. Yeah, now, next. The watermelon hits the floor surface and breaks upon landing. What is the change in momentum of the watermelon when it hits the floor? Okay, I told you there, momentum formula, they never give you any extra formula. They only give you momentum is mass times velocity. You want to find the change. Change means what? I asked you to find, hey, what's the change in temperature? Then you take the temperature now and you minus just now punya temperature lah. Right now. So change in momentum also same. You take the momentum now, the latest momentum, and then you minus the original momentum lah. Okay? So basically you take your final momentum minus your initial momentum. That's called change of momentum. Okay? Now the mass, right, is 1.5 kg for both. Okay, but what about the V and the U? Okay, so you see, right now, you hit the floor already, you know. You hit the floor already. The final is after you hit the floor already. That's the final. After you hit the floor, you are not moving already. You are zero already. So that's the final velocity. And the U is before you hit the floor. What is before you hit the floor? This one, no? Velocity just before hitting the floor. So even though this one is your V, but right now this situation is hit the floor already. So your V and U is totally different things. Your V is after hit the floor. Your U is before it hit the floor. Before it hit the floor is 7.004. Understand? Okay, so you multiply this, 1.5 multiplied by this is already not, this is 0 lah. You get negative what? -10.506. Okay, negative 10.506. Again, back to this unit because this is the unit for momentum. Momentum minus momentum is still a momentum. Okay, change in momentum. Yeah, kg meter per second. Okay, next. Take the correct statement about the impact time between watermelon and the floor surface. Watermelon and the floor surface, the impact time is very short. Okay? Impact time is very short. How do I know impact time very short? Yeah, I told you before. It depends on what? Depends on you hit the hard object or you hit the soft object. Correct or not? Hard object you hit is boom, very short time. Soft object you hit is toing, very long one. Okay? So why the watermelon broke when hitting the floor surface? It's because the floor surface is hard, right? The floor surface is hard. So you say the time of impact is short, right? The time of impact is short. And then if the time of impact is short, then you know that the impulsive force, okay? The impulsive force is large, or the impulsive force is greater, okay? So this causes the watermelon to break. Okay? But the key point is where? The key point is this one and this one. Okay? Time of impact short and the impulsive force is greater. Yeah? Okay, now last one. Give me safety features of a car. Give me safety features of a car. Hmm? Give me safety feature of a car. Seatbelt. Okay, one. What else? Besides seatbelt. Go on, go on. More. Besides seatbelt. Okay, airbag. Next. Come on. More. Airbags. And then, okay, headrest. Keep going, keep going. Don't stop, faster. We run out of time already. Seatbelt, airbag, headrest, crumple zone. Very good. Crumple zone. ABS. Okay. Some more. Keep going. Faster. Okay, very good. Very good. All right. Automatic airbag. Crumple zone. Okay, tires with threads. ABS. Okay, side impact bar, passenger safety cell, pedal dashboard, all very good. Okay, now the reason behind these things, number one, safety seat belt is to reduce the effect of inertia. Okay, because your body want to continue to go forward. You can say prevent passenger being thrown forward. Okay, prevent passenger being thrown forward. Yeah. Okay. Automatic airbag increase impact time, reduce impulsive force. Okay, just now this one we already mentioned a few times already lah. Okay, I think you should understand this already. Same for the crumple zone, yeah. Crumple zone, by the way, again, is basically the hood of the car. So when the car gets into an accident, it will go crack, 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 crack. Instead of the car just boom like that, it'll crack, 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 crack. So this will actually increase the time of the crash. Yeah, it'll increase the time of the crash. Okay, right? Now, the tire with threads, I think is the same as just now, and then the ABS also the same as just now, okay? So I'm just going to copy from just now. Tire with threads provide more grip on a slippery surface. And then the last one, ABS is to stop safely without skidding. Okay, of course, I changed this to car lah. Okay, so yeah, you can copy this down while I make my outro. Okay, so basically, for the rest of the questions, right, you can try it yourself. We will, ABS stand for this, anti-lock braking system here. Anti-lock braking system. ABS. Okay. So for the rest of the questions, you can try it yourself. I'm not sure when they will upload the answer, but I think you can try to check maybe tomorrow or the day after tomorrow. Okay. It should be you. I think you can get the link from the website, right? TTC website. Now, if you want like video explanation, basically like me in a video explaining the question, then you can head over to my YouTube channel. Okay, my YouTube channel is Wei Physics. All right, there are some videos there already. I will try to find time to record more. Okay, so if I got the time, then I will try to record some of the questions in this paper as well lah. Okay, the ones that we didn't discuss. Okay, but I also got do other papers lah. Basically, I get the questions, whichever question I want to do, then I just record only lah. Okay, right. So yeah, basically that's it. Right for today. Like I said, 2 hours. Very, very little time. Yeah, we can barely do 4 questions only. Okay, so if you got any questions, please ask, right? If you got no questions, then I won't see you next week, because next week is Form 5 already. I will see you in normal class lah. Okay, yeah. So see you when I see you. Okay. All right. Thanks for coming. Thanks for spending your Sunday afternoon. I'll see you guys soon. Okay. Bye-bye. All right. Thank you. Bye-bye.